So what is the difference between the empirical formula and the molecular formula for a compound? Well, the empirical formula is the simplest ratio of atoms of different elements in a compound. And this is commonly what we are asked to find in questions, so simplest ratio. And when we're talking about ratio, of course, we mean in terms of moles, because everything in chemistry is about moles. The molecular formula is the actual number of each kind of atom in a molecule or a substance. A good example is ethane. It comes up in most of the textbooks. So ethane, we know, has the formula C2H6. That would be its molecular formula. It's the actual number of atoms of carbon and hydrogen in the molecule. But obviously the simplest ratio would be CH3. And this is what we tend to find when we are determining the formula from combustion or analytical data. So let's have a look at this particular question. We have got an oxide of sulfur. It contains 25.1 grams of sulfur and 25.0 grams of oxygen. Determine the formula. These are very, very straightforward questions. So all we need to do is find the number of moles, and from the number of moles we can determine the ratio, and the ratio is our formula. So let's start by finding the moles of sulfur. So moles of sulfur equals the mass, 25.1 divided by the molar mass, which on my periodic table is 32.1, and that comes to 0.782 moles. I can do the same for oxygen. Moles of oxygen, in this case is 25.0. The molar mass of oxygen is 16.0, and that comes to 1.563 moles. In order to find the ratio, and this needs to be in whole numbers, we simply divide each of these number of moles by the smallest, and the smallest in this case is clearly 0.782. So if I divide 0.782 by 0.782, I get the answer 1. If I divide 1.563 by 0.782, that comes to 1.99, which is essentially 2. Now, you need to be really careful with rounding up at A level. Rounding up by 0.01 is fine. If it was like 1.25 or 1.5, you wouldn't round up, you would keep doubling everything till you got to whole numbers. But in this case, the ratio of sulfur to oxygen is 1 to 2. So the formula is SO2. In the second example, we are asked to find the molecular formula of a compound. We're given the empirical formula and the molar mass of the compound itself. So the empirical formula, once again, is the simplest ratio. And if I work out the kind of molar mass of HO, that comes to 17. We know that the molar mass of the actual compound is 34. So divided 34 by 17, I can see that essentially there are 2 units of the empirical formula in this molecule. Okay, so 2 units of HO, H2, O2. This molecule is hydrogen peroxide, and it's as straightforward as that. As a result, questions about molecular formula at A level are pretty rare because they are just really too simple, but it's good to know the difference.